Okay, here we are in 8.3. This is the first video, A, sequences and discrete functions. Now, oftentimes, sequences in series and the binomial theorem and conic sections and some of those kind of things, they're always at the end of an algebra book. And if you're really struggling to get through the material in a year, this is the stuff that usually gets skipped. So this may be brand new for some of you. It may be something that you've at least touched on before. But anyway, let's just get going with sequences first of all, and then we'll go into discrete functions. All right, so a sequence is basically a list of numbers that has a certain spacing between them. So, for example, if I had the numbers 1, 4, 7, 10, you could tell me what the next numbers are based on the what you added to the 1 to get 4, or the difference between 1 and 4, 4 and 7, 7 and 10, 10 and 13. So anyway, that's called the difference. It's called a common difference. That 3 that I have up there, and is designated with the number, or the letter D for difference. So if I had 11, 9, 7, I would know, because there's a common difference of -2, I took 2 away from each one of these, that I know I've got 5, 3, 1. If I were to have a list of numbers, a list of terms, and I went from 1/2 to 2/3 to 5/6, the way that you would find the next number is to know what the difference is between each of these, and it will always be the same. The difference here and the difference here will be constant. So what I would do here to find that is I would make this into 3/6 and this into 4/6. So therefore I know that the difference between here is 1/6. So there's 1/6 here, and then I add 1/6 here. So 6, 6, or 1 would be the next number, and then I'd add another 6 to find the next number, and another 6, etc. So that D is very important. And one of the things that you noticed here is that we're talking about the addition of the common difference here. Okay, so we added -2 and got 9. Added that, added it here, and added it here. Okay, it has to do with addition. Arithmetic sequences have to do with addition. And the formula they use in order to do a series, an arithmetic sequence, I guess I should say, is a to the n equals a to the n minus 1 plus d. Okay, when they give you a formula like that, it's always confusing because it's just got a bunch of letters. Okay. One of the things that's important is the a to the n, the a to the 1, the a to the 2, whatever. Those are place values for numbers. Okay, they are not the actual numbers. So, for instance, let's use the example that I gave you a little bit ago. 1, 4, 7, 10, ... Okay? The difference between, the common difference is 3. And let's say that we use this formula. Okay, so let's say that we want to find the next number in this series here. First of all, this is place value 1, place value 2. Okay, it's just where it occurs in our list. Okay, this is the fourth number in the list. That's what these mean. These do not mean that this is number 2, this is number 3, this is number 4. This means it's the second number in our sequence. So this here means whatever number you're looking for, let's say that we're looking for the fifth number. So I'm going to say it as a to the fifth, and that's going to equal a to the one we're looking for, the fifth one, minus 1, plus the common difference. Okay, so the way I would find the fifth number is I would find the fourth number, 5 minus 1, and then add 3 to it. And in this case, my fourth number is 10, so I add 3 to it to give me 13. So the fifth number is 13. Okay, so I'm going to put a 13. I'm going to put a 13 there. Now let's say that I want the sixth number. I'm going to take the a to the 6 minus 1, and I'm going to add 3. So my a to the 6 will be my fifth number plus 3. So a to the 6th is 16. Okay, that's pretty much it as far as arithmetic sequences are concerned. But the key part here is remembering that these here represent the place of the numbers that we're looking for. So the a to the 5 means I'm looking for the fifth number in the sequence. If that were a to the 42nd, that means I'm looking for the 42nd number in the sequence. So the first, second, third, fourth, fifth, all the way up to 42. It has nothing to do with the value of the number in the place. We're not looking for a 42 along here. We're looking for the 42nd number as they're listed here. Okay, very, very important to remember that. And it does make life so much easier when you're doing these. All right, so let's go ahead and look at, first of all, example 1. We've kind of skipped a bunch of stuff as I tried to explain some of this, give you a little bit more of an idea of what's happening. But example 1 says a to the n equals 8 over n. Okay, n basically just means any number, whichever number we're talking for. So in the example here, they say find the first 4 terms of the sequence for n equals 1, 2, 3, 4. Okay, so defined by this here. Okay, so what they're saying is the first number in the sequence is going to be 8 over 1, which is 8. The second number in the sequence is going to be 8 over 2 equals 4. And I'm doing all of these on purpose because I want you to see what's going on here. A to the 4th is going to be 8 over 4, which equals 2. So what I just found is, in my sequence, I go 8, 4, 8 thirds, and 2. So just a reminder, the 1, 2, 3, 4 are the place values. The first number is 8, the second number is 4, the third number is 8 thirds, the fourth number is 2. So this is a to the 1, a to the 2, a to the 3, a to the 4, meaning a to the 3 means the third number. That's all that means. Okay, it's huge to remember that. Okay, and they do the exact same thing with b, only instead of just a real simple 8 over n, you've got -1, and then you put your numbers in their place. Let's just kind of look at n equals 2, which is the second number they're looking at. Okay, so we've got 1 times 2 times 3 equals 6. So the number in the second place is a 6. That's what that means. Okay, so example 2, depreciation. So we've got this firm depreciates its $900,000 building, and they depreciate it over 30 years by the straight line method, which I have no clue what that means, which depreciates the value of the building by 900,000 over 30 years, which equals $30,000. Okay, so it depreciates $30,000 a year. So at the end of the first year, it's going to be worth $870,000 because we took 30,000 from the 900. Okay, so this is our difference. Okay, that's our common difference. The next year, it depreciates another 30,000. So now we're down to 840. So see how the difference, common difference goes down the same each year. So this is the end of the first year. The second year, the third year, we're going to be down to 810. Fourth year, we're going to be down to 780. And the fifth year, we're going to take another 30 off and be worth $750,000. Okay, so that's just pretty much what's going on there. Okay, not terrible. Note that the difference of terms of an arithmetic sequence is constant. It doesn't change. It doesn't, every time we do this, we subtracted 30 or we add 30, depending on what the difference is. If you're depreciating, you're taking away 30. If you're appreciating, you're adding 30. And that's a huge deal, which means that when you graph this, it gives you a straight line, and this is also important, the common difference is going to be your rate of change, which is going to be your slope. Okay, so just something to remember there as you're doing these. Now, if we're dealing with what is called an nth term of an arithmetic sequence, so what I mean there is, let's say that I'm interested in the 427 position. So we've got all these numbers, all these until we get to 427. What number goes 427 numbers down the line? Okay, or any number. And that's why I say a to the n. That means any number that we want to deal with is going to be able to be figured out using this formula. My any number is going to be my first number plus the place value I'm looking for times the common difference. So let's say, for example, that I was looking for the 427th number. So I'm looking for the 427th number. That's going to be my first place value number, and let's say it's 3. Okay, that's my first number, plus n. What is my n? Well, we just said it was 427. That's the number I'm looking for, minus 1 times the common difference. So let's just make up a common difference, 7. Let's just say that's what it is. That, when I do the math, that will give me the number that's in that place value. 427 numbers down the row. This number here, when I do the work, is going to be the number that fits into that place. So let's look at a real example here using this formula. Okay, so let's say I want to find the 25th term. I've got the sequence of numbers that just goes on and on and on. I'm looking for the 25th. So the place value is the 25th. That will be equal to A1. What is the first number? First number is a 1. Plus, again, I'm looking for the 25th number, minus 1, times the common difference. Well, what is the common difference here? 1 to 4, 4 to 7, 7 to 10. The common difference is 3. So the 25th number will be 1 plus 24 times 3, which will be a to the 25 equals 24 times 3 plus 1 is 73. So this number here will be over in here somewhere. Once we hit number 20, the 25th position, 73 will be in its place. So that's what this formula does. This formula gives you an opportunity to find whatever position the number in whatever position that they give you. Okay? So, example number 4 we'll start on in the next video.